All right, we are on 6.1 video and on operations on functions. So we've done this in the past, and should just be a review, but now the difference is we're going to look at domain and range and look at any restrictions. So here we have the four operations. We have addition, subtraction, multiplication, division. And we did this in chapter 6, but we did with just polynomials only. So here is a breakdown of what you should know. Our vocabulary for this section is only composition of functions, and we're going to talk about that a little bit later. And our objectives is to find all four operations of the function and to find the compositions. So let's just dive right into it. So when we talk about operations, these are our four operations on page 385. So we have to see when we have f plus g of x is equal to f of x plus g of x, we can break them down separately and then combine them. Same thing when we have f minus g of x. This means f of x minus g of x. And all we're saying is f of x and g of x are fancy words for y equals whatever the equation is. And the reason why we give them different letters, f and g, is because we have two different equations. Like in this example, f of x is equal to 2x and g of x equal negative x plus 5. If we don't give them names with f and g's and different letters, we're not going to know which equation we're talking about. So let's dig right into example 1. So example 1 gives us f of x equals x squared minus 4 and g of x equals 2x plus 1. So they want us to find the sum and difference. So we'll start with the sum, f plus g of x. Now remember, this can be written as f of x plus g of x. So I'm going to use this so then when I evaluate it makes it much easier. So we start with f of x, which is x squared minus 4. I'll keep it in parentheses, and I'm going to do a plus. And what is g of x? 2x plus 1. So this is going to be f plus g of x. Okay, it can be written two ways. Now, I need to get rid of parentheses. I need to simplify. All I'm using is basic algebra. Since there's an implied positive one on the outside of both of these terms, I can simply drop these parentheses and then combine like terms. So then I have x squared plus 2x minus 3. And that is my answer for f plus g of x. Now, what if I needed to do the difference? Again, this can be f of x minus g of x. And this is really important because of this minus. So let's start with f of x. So we have x squared minus 4 minus, right, I have a minus sign. What is g of x? I'm going to put parentheses, 2x plus 1. Now we all know that a minus 1, if it's outside of parentheses, we have to distribute it because that has a different value than positive 1. Negative 1 will change things, so it's opposite. So here we have x squared minus 4, and I have to, since I have more than one term, I have to distribute that negative, so it becomes minus 2x minus 2, and then when I simplify and I combine like terms, I get x squared minus 2x minus 6. If I did this correctly. Oh. 5. Sorry, I can't add. I changed this to 2 and it should just be 1. So it's minus 5. This is my answer. And that is what the difference of the f minus g of x equal to. All right, so this is the sum right here, and this is the difference. Now, we also have to look at the domain and range. The domain and range, when we add and subtract functions, is the result of the combination of them two together. So we look, is there any restrictions on this domain or this domain? This is a parabola. This is a linear equation. You should realize that. So the domain for both of them are all real. Therefore, the domain and range for these two have no restrictions, will also be, the domain is going to be all real numbers. The range will have some restrictions because you have a parabola. All right? So adding and subtracting is pretty easy. You just take the function 1 plus function 2. Now, addition, order doesn't matter. We have a commutative property. Subtraction, order matters. So if I wanted g minus f of x, then I would have to write it as g of x minus f of x. And that negative now you see will be distributed to the f of x instead of the g of x. So order matters in subtraction. Don't forget that. Let's look at example 2, where they want us to find the product and quotient. So it's really important to know that this here means product because it's a closed circle. Now, if I wrote this, and we're going to learn this in a minute, they're not the same thing because it has an open circle. That means composition. It's a whole different function. So we'll talk about that in a minute. Know the difference. When it's a solid dot, that implies multiplication, the product. So we can rewrite this to say f of x times g of x. So they tell us that f of x equals x squared plus 7x plus 12, and g of x equal 3x minus 4. Now, so again, I'm going to break them up separately. And I'm going to start with f of x times g of x. It's going to equal to x squared plus 7x plus 12. And I always start off with my parentheses. I may not need them, but I don't want to run the risk of missing a number or a sign. Okay, so now I have a trinomial times a binomial. So you can do it vertically, you can distribute. We did it both ways last semester, so I'm just going to simply distribute, go this way, and then I'll take this term and distribute to all of these. Okay, so when you multiply this out, so I start with 3x times x squared, so it's 3x cubed. 3x times positive 7x is plus 21x squared. 3x times 12 is plus 36x. Minus 4 times x squared is minus 4x squared, because remember this is a minus. Minus 4 times 7x is minus 21x, and minus 4 times 12 is minus 48. Now I've got to combine like terms. I get 3x cubed, 21 minus 4, because these two are like terms right here. So 21 minus 4 is plus 17x squared. 36 and 21 is going to be 15, so that's a plus 15x, and then minus 48. And there's my answer. Were there any restrictions? I have a parabola and a linear equation. The domain is all real numbers, so there are no restrictions, and domain is all reals. Now, here's where we get a little tricky. When we want to find f of g of x. So what we're saying is we want to find f of x divided by g of x. So now I have a fraction. And can I have restrictions? When is this function undefined? Remember, when we have 0 in the denominator, our function is undefined because we can't divide by 0. So if I have a variable in the denominator, I have to set that equal to 0, the entire denominator, and find out when will that become 0. At what value or values will x make the function 0, which would make it undefined. So let's start with our equation. So we had f of x, so it's going to be x squared plus 7x plus 12. That was f of x. And g of x was 3x minus 4. Well, what you want to do is you want to factor. This is not factorable. Just so you know, it's not going to be factorable. Well, it is factorable, but it's going to equal to x plus 4 times x plus 3. And even though they've got the same numbers, they have to be exactly the same because of these plus. These parentheses make them separate factors. So in order to simplify, they have to be exactly the same. Since none of them simplify, I'm going to leave it in this format because I can't reduce any further. However, I have a variable in my denominator, so I have to take 3x minus 4 and set it equal to 0. When will this, at what value of x will f of x equal 0? So I set it equal to 0, and I just use algebra. Okay, so when x is equal to 4/3, I'm going to get 0 in the number, which makes this function defined. So the quotient of these two functions, this is the answer, and you must include the restriction x cannot equal 4/3. Okay, so that's the restriction on the domain. So when we have the quotient, we always have to look, is there a variable? Only if there's a variable in the denominator. If there is, we have to set the whole thing equal to 0 and solve for x, and whatever value. If this is a parabola, we're going to get two solutions, obviously. We need to find out when it's undefined. Okay? Now let's talk about composition. So composition was one of our vocabulary words. And we said it's when where the results of one function are used to evaluate a second function. Okay, so what does that really mean? If you go back and you look at our book and turn to the next page, and if you look at the video notes at the top, before we get there, let's just give us an example and show the domain and range of when we take the sum and difference of two functions. So they give us two functions, and they make a table of x's, and they put that into f of x and get the y's. Then they put it into g of x to get the y's for that. So you see a set of coordinates here, -3, 9 for f of x, -3, -3 for g of x. And then when they compose the two and find the sum, this is the result, and then they put this same value into the sum of the two functions, and they get these y's. So they graph those, and the dotted lines are the f of x and g of x, and you can see the solid line of the parabola. The domain is still all real numbers. Same thing when we find the difference. They did the same thing here, and the domain's the same. So the domain is just going to be the intersection of the two functions. Unless there's a restriction, it should be all real numbers. All right, so let's look at this one. We're going to talk about, we already talked about multiplying division. Now we're going to look at the composition, which can be a little tricky. So basically, if we have two functions, f and g, okay, such that this tells us the range of g when we're talking about fog. So you start from the inside and work your way out. So the range of g is a subset, or is in the domain, or part of the domain, another way of saying it, of the function f. And then the range from there becomes a range of fog. All right, so this can be written fog or goff, and I'm going to write it a different way, the way they wrote it up here, and explain this a little better. So they're not necessarily equal, so order matters. And what we're saying is, if I have fog of x, another way to write it is f, I'm going to use brackets so you can see g of x. All right, so, and goff of x is going to equal to g of f of x. And that's important because order does matter, and these two may not necessarily equal the same. So let's dig right into an example with coordinates. Okay, so we look at example 3. They want us to find fog and goff. If they exist, state the domain and range for each composed function. This is called a composed function. So now, they give us f equals, and they give, instead of giving us an equation, which we are used to, which we've done before, they give us some coordinates. And they give you coordinates so you can understand what composition is. All right. Oops, it's just equal, sorry. And it's 8, 15, and 5, 1, and 10, 14, and 9, 0. Okay, so first of all, we're going to start with fog. And we said it can be rewritten to say f of g of x. All right, so that is what we are composing. That's what the little circle means, compose. So we start on the inside, and I'm going to say g. Remember, we start with the domain of g. So I want to say g of 8 equals g of 8 equals 15. So the range of 8 is 15. So I'm going to do f of 15. Okay, because remember we said the range of the inside becomes the domain of the outside. So then I want to do f of 15. And what do I get? 11, right? Then I'm going to do g of the next one of 5. Okay, and I'm going to get f of 1. Then I'm going to do f of 1. I go to f, here's my f function, and f of 1 is 8. Remember, it's just the y value. Okay, there's 1, there's 1. Then I'm going to do g of 10, and I get 14, right? And I want to do f of 14, which equals 9. Then I'm going to come over here and do g of 9, gives me 0, right? So now, or f of 0, so f of 0 is going to be 13. So what is my composition? What does this equal to right here? Okay, so let's look at that. So we take the domains of g, so 8, 5, 10, and 9. Those were my domains that I use. Okay, and I put them in, I found the ranges of them, and then I did f of those. The result was 11, so this becomes 8, 11. This becomes 5, 8. This becomes 10, 9. This becomes 9, 13. So this is my composition function, are these coordinates. What's a domain? It's just all the x's, which would be 5, 8, 10, and 9. Oops, I did put them in order. So that would be the domain of the composition, fog, and the ranges would be all the y coordinates, which is 8, 9, 11, and 13. Okay, so that's my domain and my range, and this would be, so if I asked you to compose using Goff, this would be the answer, with this being the domain and range. So domain are just the x's and range is the y. Now let's look at the Goff. I'm not going to rewrite all those values. So remember, this is g of f of x. And I should have written it that way from the get-go. So g of f of, again, we go to f and start with each domain of f. So we have 1, we have 0, we have 15, and we have 14. Oops, I did it wrong. Oops. So we start with, yes, f of 14. Okay, because for Goff, we start with f of x first. So I take all the x's of f. And if you look, all my f's are 1, 0, 15, 14. That's how I got these numbers. F, 1, 0, 15, 14. So what is f of 1? That's what I start with. What is its range? It's going to be, this one's going to be, which tells me I need to do g of it, 8. What is 0? It's going to be 13. What is 15? 11. What is 14? 9. Okay, so I'm going to change the color here. So when I do g of 8 and g of 13 and g of 11 and g of 9, I go to g, and the first one was g of 8. So I go to 8 for g. What's its y value? 15. So this is going to equal to 15. All right. Then I go to g of 13. There is no 13 in the x. So guess what? This one is undefined. Then I go to g of 10. Oh, sorry. G of 11. There are no 11s in the x-coordinate of g. So this one is also undefined. Now I'm going to do g of 9. Is there a 9 in the x-coordinate? Yes, and that result is 0. Okay. So the only two that exist are these two right here. These two don't exist, so my answer for golf of this is going to be, I start with the domain of the first one, 1, and then the range of the result of the composition is 15. And this one is 14, comma, 0. That is my answer. The domain is 1, comma, 14. The range is 0, comma, 15. They have a mistake in the book. They've got a different domain and range, but this is the composition of the two. Okay? I'm not going to test you or expect you to know this, but test you over, but you need to understand and know what it really means, what composition is. So let's look at one with functions, which you're used to doing, which is going to be example B. All right? So they give us f of x equals 2a minus 5, and g of x equal 4a. So they want us to find fog of x. Okay, so the first thing we're going to do is we're going to start with g of x. You always start with the inside, which is 4a. Now I need to do f of that. Remember, that's now the range of 4a. So I'm putting this in wherever I see the a value for f of x. So this becomes 2 times 4a minus 5, which simply equals 8a minus 5. And there's no restrictions on either one, so the domain is all real numbers. Now, what about golf? That's a whole different one. So remember, golf of x, we start with g, and I'm going to rewrite this one. I didn't do it to the other one. Is how we're going to do it. So we start with f of x, which is 2a minus 5. Now, then I put that into here, that result. So that result is 2a minus 5. And we put that into g of x. So it's 4 times 2a minus 5, right? Because this is g of x. I'm putting this in for a. And I just distribute. So I get 8a minus 20. All right? So these are a little bit easier. This I will expect you to know how to do. So do the problems, and we will see you in class.